We're going to look here at a tricky AS1 mathematics question, which is to do with binomial expansion. It uses an identity which you don't really have to use that often in AS1. More likely it's going to come up in A21, your year 14 exam. The identity is this: if you have 1 plus x to the power of n, then that is the same as 1 plus nx plus n times n minus 1 times x squared, and that's over 2 factorial. Then I'll just do one more, and then that plus, then it would be, the next term would be n upon n minus 1 times n minus 2 times x cubed over 3 factorial. Now that isn't, I say, doesn't come up that often in AS1, but it is sometimes useful, so I think probably that's what I would use in this particular question. So I'm just going to rub that out and we'll come back to it. So this question says, given that 1 minus x upon 1 plus ax to the power of n is equal to, identically equal to, 1 plus 23x plus 228x squared, find the values of a and n. Okay. First thing I'm going to do is I'm going to expand this thing, the 1 plus ax to the power of n, using what I've got. And by the way, what I just put on the screen, that is given in your formula booklet, thankfully. So we're just going to look at this. So for our solution, we're just going to look at 1 plus ax to the power of n. So that's going to be 1 plus, and it's going to be n times ax. Instead of x, it was ax. And then the next term would be n times n minus 1 times, instead of x, it's ax squared, and then that's divided by 2 factorial. There is no need for me to go any further because over here we only go up to the quadratic term, so there's no point in going any further. I'd be wasting my time. So if we do this, we just multiply this out a wee bit and see what we get. Just tidy it up a wee bit. That's just going to be 1 plus anx, and then plus, and here, this is a bit people mess up. Square the x, it's clearly x squared, but people forget to square the a. So a squared will become a squared will become a squared. So it's just going to be a squared times n minus 1. I'll just leave it as that, and then times my x squared, and 2 factorial is the same as 2. Okay, now that means I will just say, therefore, if I did 1 minus x times 1 plus ax to the power of n, that is the same as 1 minus x times 1 plus anx plus a squared times n minus 1 times x squared, and that's divided by 2. Okay, so again, I only need to go as far as the quadratic terms. So let's just multiply that out. Okay, multiply through everything through by the 1 then. 1 times it is just going to be 1 plus anx plus a squared n times n minus 1 times x squared. That's still over 2. And now we're multiplying through by our minus x. So multiply through by minus x. Minus x times 1 is just minus x. And then we have got minus x times anx is minus anx squared. And thankfully, I don't need to multiply the next term out. It would be minus x times an x squared term, which would give you an x cubed term. So I have no need to do it. So I'll just stop there with what I have done. Okay, now let's tidy up. Now the reason I'm tidying up is I want to collect my numerical terms. That's it, just a 1. And then I want to collect my x terms. So my x terms, I have an anx and I have a minus x. So that's the same as an minus 1 times x. And then my quadratic term is just, I've got 2 quadratic terms. I have 2 quadratic terms. I'll put that in a bracket. I have a squared n times n minus 1, that's all over 2, minus an, and that's times my x squared. Okay, this is going to be a tricky question, unfortunately, but we're just going to have to go with it. Okay, right, now what we have got, you can see what our quadratic terms are. And if I zoom in up here, on my right hand side, my quadratic term, my linear term, my x term is 23. And down here, my x term is an minus 1. It is an minus 1. So that means we can equate those two things. So what I'm doing here is I'm just saying equate the coefficients of x, and that means, what have I had up there? What was that? Sorry, 23 then is equal to, so 23 was equal to an minus 1, which means 24 is equal to an. Okay, if we go back up to the top and we look at our x squared term, and this is going to be the awkward one, our x squared term, we had 228 was our x squared term, and down here, our x squared term was this horrible thing down here. It was equal to this. Okay, right, what we'll do with this then, so what have I just said there? We'll do equate our coefficients, bear with me a second, just fighting with this thing, equate coefficients of x squared, and we had, forgotten already, 228, so 228 was equal to this horrible thing here, which was a squared n upon n minus 1 all over 2, and then minus an, that was what was multiplying my x squared. Okay, as ugly as this is, it's simultaneous equations. You have an equation here with two unknowns, and you have an equation here with two unknowns. Okay, now, this is a very difficult thing to do, so we're going to use any wee cheats that we can here. So first of all, I can see here that an is equivalent to 24. So this here, this an here, I could write that as 24. That would make life a heck of a lot easier. So I will do that first of all. So I'm just going to say then, this becomes 228 is equal to a squared n upon n minus 1 all over 2 minus 24. Bring that 24 across. So 228 plus 24 is equal to 252. Sorry, this thing keeps changing on me, I don't know why. It is equal to 252. So 252 is equal to a squared n minus 1 all over 2. Then we could multiply across by that 2 as well to make life a little bit easier. We'll have 504 is equal to a squared n minus 1. And also, we could, now I'm going to have to do something else in a wee minute as well, but I could also write my an here. A squared n is the same as a times an times n minus 1. So that's the same again as 504 is equal to an, remember, was at 24. So that's 24 times a times n minus 1. And then, does that divide by 24? It does indeed. If I divide across by 24, I'll get 21 is equal to a times n minus 1. And then we've hit a wall. Okay, so that's what our equation 2 became. We're now going to look at our equation 1 up here. And from this, I could write then that a divided across by the n is equal to 24 over n. So we're then going to sub that into this. So just say sub in a is equal to, what have I just said, 24 over n, which means 21 is equal to 24 over n times n minus 1. And then it's going to become a quadratic. Multiply across, it's not even going to become a quadratic at all, it's going to become a linear. Multiply across by your n, you'll have 21n is equal to 24 times n minus 1, which means 21n is equal to 24n minus 24. File the 24 across, becomes positive. Bring the 21n across, you'll have 24n minus 21n. So you'll have 24 is equal to 3n. N then equals 24 divided by 3, n equals 8. And your a, remember, was equal to 24 divided by 24 divided by n. So a is equal to 24 divided by 8. Therefore, your a is equal to 3. And there we have it. Not easy at all. I would imagine that's as hard an AS1 binomial question as you could get.